So hello and welcome to the continued coverage of the walkthrough series. And in this episode, we are looking at May, June of 2021, variant 4.1, and we are doing the Python implementation for question 1. So let's go ahead and jump right in. Question 1 here says that an unordered list, linked list rather, uses a 1D array to store the data. Each item in the linked list is of record type node with a field data and a field next node is it. So the current contents of the linked list are, then we're given the diagram, a visual representation of what the linked list currently looks like. So the start pointer is set to 0, then the empty list is set to 5, then we have the data and the nodes as well as the indices there. So our task here on part A is to create code to declare the record type node is it. So we are given this type declaration in pseudocode, and we are supposed to implement this using program code. So let's actually switch to the tab where I have my solutions going on here. On lines 9 to 13, that's where I have my declaration for the node record. So you need to remember that in Python we do not have a record type like in pseudocode, is it? So the way we can do that, or rather go about it, is to use the class to create it as a class as it were. So we have the class declaration there, then of course we have the constructor going on. Because whenever you have a class, you also need to specify a constructor so that we can set those parameters that are given. That is the data node as well as the next node. And of course, you'd go ahead and copy this code and paste it inside of your evidence document. Then moving on to part B, we are to write program code for the main program, which essentially is going to declare a 1D array of type node with identifier linked list and initialize it with the data shown in the table on page 2. Then we are also to declare the pointers. So essentially, they want us to create the linked list as it were. So let's actually go ahead and look at that. So the way I went about it was to come outside of the main method. I have my main method down here. Right? So what I did was to create a separate function called initialize linked list. Then inside of it, I then set the values that are given in the question. So you remember that the constructor for the node class takes 2 arguments, right? Remember, self is always the first parameter that you're going to pass to any method inside of a class in Python. So that's why we have that going on. I cover that in more detail in my Python series, so you can always check that out if you want an in-depth coverage of the syntax that's going on here. So the data and the next node. So here what we have going on is the data and the next node is it, and this is just as given in the diagram right here. So we do the same for the rest of the nodes. Then we are also going to initialize the start pointer to 0 and the empty list to 5 is it. Then what we do now is to come inside of main method, the main method right here. Where's my main method? Right here on line 89 here. So you see that we declared start pointer and empty list outside of any functions or outside of any methods. So we are making use of the global keyword, right? So that the main method knows that we're referring to start pointer and empty list that we did initialize here on lines 17 to 19 there. Then of course, maybe one more thing that I need to comment out is the linked list right here. So you see that we are initializing our linked list with none. So none simply means that it's a null value. There's nothing in it. So it's not equivalent to 0. It's not equivalent to anything. It just means that it's null, or there's nothing in it as it were. So it has a size of 10. You see that we're multiplying it by 10. Then of course we then give actual values inside of this initialize linked list method or function as it were. Then of course you'd go ahead and copy the code and paste it inside of your evidence document, because we are just initializing as per the requirements on part B here. Then part C says that we should create a procedure called output nodes that takes the array and start pointer as parameters. The procedure outputs the data from the linked list by following the next node values. So we have to write program code for the procedure output nodes. So we have to satisfy these requirements right there on part C for C item 1. So let's actually go ahead and look at my implementation going on from lines 35 to 47. So we have the list array, which is going to be the first argument or the first parameter. Then we're also going to have the starting position. Then we are setting current to start. Then while the current position is not equal to -1, it means that we are going to add the data as it were, then print it, right, as per the requirements, right? Because you're supposed to take the array and the pointer as the parameters, then the procedure outputs the data from the linked list by following the next node values. So that's what we're essentially doing right here on lines 43 to 47. Then, of course, you go ahead and copy the code and paste it inside of your evidence document. Then part C item 2 says that we need to edit the main program to code the procedure output nodes. Then we are also to take a screenshot for output nodes. So let's actually go ahead and do that. I can just hit on the play button here. And then just give it a second for this thing. So you see that this is the output that we're going to get, is it? So the current linked list contents are going to be these ones. Then of course you go ahead and copy the code and paste it inside, rather take a screenshot and paste it inside of the evidence document. Then we move on to part D. So we have the function add node that takes the linked list and pointers as parameters, then takes as input the data to be added to the end of the linked list. So the function adds the node in the next available space, updates the pointers and returns true. If there are no empty nodes, it returns false. So we want to implement this add node function. So let's actually go ahead and look at the implementation that I have going on here. This is my main method. All right, so this is my my add node method right here. So here you have the three parameters as specified, right? So you see that we should take a linked list and the pointers. So we have the linked list and the pointers there. Then of course, this is just a comment describing what the function does because it's required. If you are using Python, if you check out the instructions at the start of the page, you see that they say if you are using Python, you should you should comment out most of your code really, as it were, because Python for the most part it's dynamically typed. So it means that when you type a variable or when you type a function, you actually don't really know what it does until, rather the interpreter doesn't really know what it does until at runtime. So that's what we're essentially doing here, just describing what the function tries to accomplish. Okay, so we have the empty list, then we are checking to see if it is -1, then we are satisfying this requirement which says that if we can't return, rather if we can't add a particular node, where is it? Right here. Then updates the pointers and returns true or false, right? So that's what we are trying to accomplish here. So if if it is empty, then we are going to return false. Otherwise, we are going to try and add, find the first node in the list. Then we are going to say that is the start, and that's going to be the current. Then the previous is going to be -1. Then while the current node is not equal to -1, then we are going to take the previous and set it as the current. Then we are going to take the current node that is inside of the next of the list array that we passed as an argument right here, and then store it as the current. Then we are going to add the new the node to an empty position. So we create a new node, pass the data, right, as well as the pointer there, and then we are going to put it inside of the list array at the empty slot there. Then we also need to update the last pointer after we've added a new node to it, because that's how a linked list works. I go into great detail covering how linked lists work in one of my animated videos. I call it the animated series. It's on my channel, so you can always check that one out. Then, of course, lastly, we need to update the empty list pointer to the next available space. So that's what we're doing on line 85 there. Then return true. So for this, you would get 7 marks. So you'd go ahead and copy the code and paste it inside of the evidence document. Then we need to edit the main program to call node, output an appropriate message depending on the result returned from node. Then we also need to call output node twice before calling add node, once after calling add node. Then we have that going on down here in main. So C item 2, we are calling, actually it's the item 2. It's the item 2. All right, right here. So we want to add the value 5. What is this? Did I cover? Did I cover C item 2? Wait. Add the main program item 2. Alright, so this is C item 2. So this is D item 2 right there. So the item 2, what you're supposed to do is we need to, we have the function. So we wrote the code with the function. We need to call add node. So we are calling add node right here. Then remember that add node is going to return a result. So we are simply going to take that result and store it inside of this result. Add node returns a boolean true or false. So we are going to take that value that has been returned and store it inside of result here. Then if result is true, then we are going to say that the node has been added successfully. Otherwise, we're simply going to print that we failed to add the node because we don't have any space. So we do that, then we output an appropriate message. So that's what we're doing on lines 104 to lines 107. Then call output nodes twice, once before calling add node and once after calling add node. So here we are calling after addition. Then did I once before calling add node and once after calling add node. Okay, I think I didn't call add node for the second time around. Let me see. Output nodes twice, once before calling add node and once after calling add node. Alright, so here after addition. So I should have called it before addition. So we are adding right here. So output nodes. Alright, actually the code was mixed up. It's this code is supposed to be right here. Let me copy this line. Then let me just paste it here. Then what I can do, I don't want that extra space there. So let me just copy this line and paste it here. Then I will just change before addition so that we have that going on there. All right, so I think now we satisfied this requirement. That was a bit of oversight on my part when I did this, when I was preparing the solution. Then we need to test the program by inputting 5 and taking a screenshot. So we are passing 5 right there. Then we need now to run the program. So let's go ahead and run the program. So it's compiling. So you see that before addition, we have that going on, right? So this is before addition. Then we are now adding the new node value 5. Then the node has been added successfully. Now we simply print out a linked list after addition. So now you see that the 5 has been appended at the end of the linked list there. So yeah, I think that's just about it for this video. Make sure that you don't have any questions. So next up is video for number 2. Hopefully you learned something, and I'll see you in the next one.